This is an instructional video on how to compare two or more functions. So when we're comparing functions, we first need to find the rate of change. Remember, that's the slope. And you also need to find the initial value. Remember, that's also called the y-intercept for each function. Meaning, if you have two functions, then you're going to have two rates of change and two initial values. If you have four functions, you're going to have four rates of change and four initial values. If you need to, go back and look at the graphs, tables, equations, and word problem videos to help you. Once you have both rates of change and initial values, your ultimate goal is to think about what statement you can make. Using the data, using the rate of change and initial value. What statement can we make? For this problem, it says the table and graph show how much money a store earns selling each team t-shirt and each team cap. Compare the rates of change for these two functions. Now, this problem only asks for the rate of change. We do not need to find the initial value. To work for the table, we're talking about t-shirts in the table. To find the rate of change of a table, we want to see how much we're changing by. How much are we going up or down? 1 plus 1 is going to give us 2. 2 plus 1 is going to give us 3. 3 plus 1 is going to give us 4. On the opposite side, 4 plus 4 is going to give us 8. 8 plus 4 is going to give us 12. 12 plus 4 is going to give us 16. Now, when we go to write our slope, we write it as a fraction, y over x. In this case, our y value is 4 and our x value is 1. And so our slope, our rate of change, is 4, meaning they earn $4 for each t-shirt. That's for the table. Now, for the graph, we're starting here at 0, and so we're going up 2 and over 1. Remember, we write it as a fraction, y over x. We go up or down first. Remember, up is positive, down is negative, and then always to the right-hand side. So in this case, we're going up 2 and right 1. And so our slope, our rate of change, is going to be 2. Now, what statement can we make from that? It means that they earn $2 for each cap. A cap is a hat that they sell. So when we're comparing them, we make each of those statements. They earn $4 for each t-shirt. They earn $2 for each cap. Those are our two statements. And then our overarching statement is that each cap costs $2 less than the t-shirt. You could also say that the t-shirt costs $2 more than the caps. Either statement is fine, but we want to make a statement about each individual function and then about the function as a whole. 3 statements made in this problem. For this problem, it says below are two companies' rates for textbook rentals. What is the initial value for each function? What is the cost to rent a textbook for 4 months from each company? So for this problem, we're just looking for the initial value. The initial value in the equation for company A, C equals 15M plus 15, where C is the total cost in dollars and M is the number of months. Remember, we use the equation y equals mx plus b. Even though they use different variables, it's still in the same format. The y, the c value is by itself. The mx, the 15M is together, and the plus 15, the plus B, is at the end. Now, the initial value is represented by the letter B. So for company A, the initial value is 15. It's that B value, the plus B value here. Now for company B, it says $19 per month per textbook. It does not have any additional fees. This $19 per month is going to be the rate of change. The word per tells us it's the rate of change. And there's no other information. So that tells us that there is no initial value. So company B has an initial value of 0. There is no initial value for company B, so it's 0. So what overarching statement can we make? We could say that company A has a greater initial value. Notice, we made a statement about company A, we made a statement about company B, and we made a statement about both companies. Company A has a greater initial value than company B. Now, there is an extra question to this problem. It asks us, what is the cost to rent a textbook for 4 months from each company? So for company A, 4 months, we would do 15 times the 4 months plus the $15 initial value. So when we solve this problem, we would do 15 times 4, which would give us 60. And 60 plus 15 is going to give us 75. Company A costs $75. For company B, it's $19 per month. So we're going to do 19 times our 4 months. 19 times 4 is going to give us $76 for company B. We could say that company B is $1 more than company A. For this problem, it says the equation and table show what 2 boys pay for gym fees. Compare the rate of change and initial value for each function. So this one, it's asking for both rate of change and initial value. So looking at Alfredo, again, for a table, the rate of change is found by counting up each time. So 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3. 20 plus 10 is 30, 30 plus 10 is 40, 40 plus 10 is 50. Remember, we write it as a fraction, y over x, and so in this case, 10 over 1, and so our slope, our rate of change, is 10. We can say that the rate of change, Alfredo's rate of change, is $10, meaning it costs $10 for 1 month. Now for Alfredo's initial value, the initial value is where it starts at 0. So when we're at 0, we're starting at 20. So for Alfredo's initial value is 20. It costs $20 up front, a $20 fee in the beginning. Now, moving on to Alex. Alex has the equation C equals 25 plus 10m. Remember, we're going to reference the equation y equals mx plus b. Even though they use different letters, C and M, it's still in the same format. I want you to notice how the 25 and the 10M are backwards. That is okay. The 10M is clearly the slope, the rate of change, because it represents the mx. The number with the variable is always the rate of change. So Alex's rate of change is also $10. Notice it's 10M, $10, meaning it's $10 for 1 month. Now, for Alex's initial value, the initial value is represented by the letter B, the ending number, in this case, the 25. So Alex's initial value is $25. It's a $25 fee up front. So we've made statements about the rates of change, both of them. We've made statements about the initial values, both of them. And so for our overarching statement, we can say that they have the same rate of change, but Alex has a greater initial value. You could also say they have the same rate of change, but Alfredo has a lower initial value. Either statement is fine. Roy wants to buy a new wireless phone for $200. 2 stores offer different payment options. Which plan has a greater initial value? Which phone will be paid for at a faster rate? So, we're looking for both the initial value and the rate of change. So looking at store A, we're going to start there. On a graph, we can find the rate of change by seeing how much we're going up or down and then over. We write it as a fraction y over x. So it's going to be up or down and then always to the right. In this case, we're going from 150 to 125, so it's going down 25. We're going over 1, 0 to 1 is 1. So that means our rate of change is negative 25. He's paying $25 each week. $25 each week. Now the initial value is the starting point. So he has to start at $150. However, the phone costs $200. There's a $50 difference. He has to pay $50 up front. He has to pay $50 at the store to buy the phone, and then he has to pay off $150 each week. So $25 each week is our rate of change. The $50 up front is going to be our initial value. Now, moving on to store B. Store B, it says pay $50 at the time of purchase and pay $20 per week until the phone is paid for. Anytime we see the word per tells us that it's the rate of change. So that one is paying $20 per week. And then the other fee is our initial value. So again, it's paying $50 up front. $50 at the time of purchase. At the store, he pays $50. So what statement? We want to answer these two questions. Which plan has the greater initial value? They have the same initial value. They both have to pay $50 up front. Which phone will be paid for at a faster rate? Store A has a greater rate of change. They're paying $25. Store B is paying $20. Store A has a greater rate of change. Ty sells signs in a monthly craft fair, and he can make 7 signs every 2 hours. His friend Harrison helps him make his signs at the rate at which Harrison makes signs is in the table below. Who is making signs at a greater rate? How do you know? So for Ty, it tells us that he makes 7 signs every 2 hours. So we can set that up as 7 over 2. If we divide 7 divided by 2, We would end up, if you simplify it, getting a decimal of 3.5, but we do want the slope to always be in a fraction, but we can reference the decimal to make it easier to understand if that's easier for you. For Harrison, we have a table. To find the table, we have to see how much we're changing by at each point. So 0 plus 4 is going to give us 4. 4 plus 4 is going to give us 8. 8 plus 4 is going to give us 12. 0 plus 15 is 15. 15 plus 15 is 30. 15 plus 30 is 45. When we set up our slope, we set it up as a fraction y over x. In this case, 15 over 4. If we simplify that, 15 over 4 is going to give us the decimal 3.75. So when we answer the question, who's making signs at a greater rate, we could say that Harrison is making signs at a greater rate. Because the question does say, how do you know? Because he makes 3.75 signs per hour. But Ty only makes 3.5 signs every hour. It says after 12 hours, what would be the difference in the number of signs that each friend has made? So for Ty, he's making 7 signs every 2 hours, or like we said, 3.5 signs an hour. So I can multiply 3.5 times my 12 hours, and we get 42. Ty's going to make 42 signs. For Harrison, Harrison's making signs, 15 signs every 4 hours, and like we said, that's 3.75 hours. So we can multiply 3.75 times our 12 hours, and we get 45 signs. But the question specifically asks, what would the difference be? The word difference means to subtract. So we're going to subtract 45 minus 42, which is 3. Our statement that we can make is that Harrison will make 3 more signs than Ty in 12 hours. Julie's family is filling up the pool in her backyard. The equation y equals 8,400 plus 5.2x can be used to show the rate at which the pool is filling up with water, where y is the total amount of water gallons and x is the amount of time minutes. Her neighbor, Elena, is also filling up their pool as shown in the table. Whose pool is filling up at a faster rate, and how do you know? So we're only looking for the rate of change. For Julie, we're talking about Julie first, the rate of change is in the equation, y equals mx plus b. The mx value is the rate of change, in which case it's going to be 5.2. Julie's rate of change is 5.2 gallons per minute. Now for Elena, Elena has the table. When we're looking at the table, we want to see what we're counting by. 0 plus 3 is 3, 3 plus 2 is 5, 5 plus 2 is 7. Going up on the other side, 7, 850, and 78, 64.4 is going to give us 14.4. 7864.4 to 7874 is going to give us 9.6. 7874 to 7883.6 is going to give us 9.6. Now, these numbers are different. That's okay. We should still get the same answer. We set up our rate of change as a fraction, y over x. So we can use either the 14.4 and the 3, which when we simplify 14.4 divided by 3 is going to give us 4.8. Or we can use the other number, 9.6 and 2, which if we simplify 9.6 divided by 2 also gives us 4.8. So Elena's is filling up at 4.8 gallons per minute. So whose pool is filling up at a faster rate? Julie's pool is filling up at a faster rate. Because Julie's pool is filling up at 5.2 gallons per minute, while Elena's pool is filling up at only 4.8 gallons per minute. Reese and Kevin have been working out together to try and lose weight. Reese's weight loss can be modeled by the equation y equals 203 minus 4x, where y is his total weight and x is the number of weeks he's been working out. Kevin's weight loss progress is shown in the graph below. Who is losing weight at a faster rate? Explain your reasoning. So again, we're looking for the rate of change. So looking at Reese, because Reese is the equation. For Reese, we can reference the equation y equals mx plus b. Remember, the mx value is the rate of change. So in this case, it's a -4. -4 represents losing, because remember it's going down, he's losing weight, losing 4 pounds each week. It's negative because he's losing weight. Now we can reference Kevin's weight loss from the graph. So for Kevin, we want to pick out the points we can read clearly. He's starting here at 200, and we're going to go down to this point here because it crosses two lines evenly. So remember, we set it up as a fraction y over x. We go up or down, and then always to the right. So going from 200 to 180, we're going down 20, so that's going to be a -20. And then over 1, 2, 3, 4 squares. So -20 divided by 4 is going to give us -5. So for Kevin, he's losing, because it's negative, he's losing weight, 5 pounds each week. So when we answer the question, who is losing weight at a faster rate, our answer is going to be Kevin is losing weight at a faster rate. Because, and you can reference our statements, because Kevin is losing 5 pounds each week, and Reese is only losing 4 pounds each week. The gas mileage of Caden's vehicle can be represented by the equation y equals 16.2x, where x is the number of gallons of gas and y is the number of miles. Ethan's gas mileage is shown in the table. Whose vehicle gets the higher rate of miles per gallon? So for Caden, we're referencing the equation y equals mx plus b. Remember, the mx value represents the rate of change, which is what the question is asking for. So in this case, Caden's rate of change is 16.2. Caden gets 16.2 gallons per mile. Now, Ethan is represented in the graph. So for Ethan, we have to look at our graph, and remember, we write it as a fraction, y over x, up or down, and then always to the right. In this case, picking out 2 points we can read clearly, I'm going to start down here, and I'm going to pick this point here, because it's represented by crossing two lines evenly. So I go up 10, 20, and 30, so it's positive because we're going up 30, and over 1, 2. 30 divided by 2 is 15. So Ethan gets 15 gallons per mile. So when we answer the question, whose vehicle gets the higher rate of miles per gallon? Caden gets a higher rate of miles per gallon. Because, we always have to explain why, and this is where we reference our statements. Because Caden gets 16.2 gallons per mile, but Ethan only gets 15 gallons per mile. The Smiths are hiring painters, and the painting companies they've narrowed it down to charge based on the number of square feet. Company A charges 2.25 per square foot. Company B's rates are shown in the table below. Which company would give their family the lower cost per square foot? So for Company A, they have an equation. Or excuse me, they don't have an equation, they have the word problem, but they do tell us it's $2.25 per square foot. That word per means that it's our rate of change. It specifically tells us $2.25 per square foot. Now for Company B, we have to find the table. So we have to figure out what we're changing by each time. 1,200 plus 200 gives me 1,400. 1,400 plus 200, that should be a 1,600, must not have printed very well, I apologize. 1,600 plus 200 is 1,800, and 1,800 plus 200 is 2,000. So we're going up by 200s on the left-hand side. On the right-hand side, we go from 3,300 to 3,850, which is going up 550. 3,850 going to 4,400 is again 550. 4,400 to 4,950 is again going up by 550. And 4,950 to 5,500 is going up 550. When we write it as a fraction, y over x. In this case, 550 over 200. 550 divided by 200 is 275. So Company B is charging $2.75 per square foot. So when we answer the question, which company is going to give the family the lowest cost? Company A is going to give the family the lowest cost. Because, we always explain why, because Company A is charging $2.25 per square foot, while Company B is charging $2.75 per square foot.